example 1, it says figure ABCD is a rectangle with diagonals AC and BD. So diagonal, diagonal. That's maybe a new word for you, a polygon. If you connect a vertex of a polygon to an opposite or opposing vertex like that across a polygon, that's called a diagonal. And we want to identify the corresponding sides and angles of triangle ABC. So if I look at triangle ABC, starting at A, going to B, over to C. And I'm going to take a look at triangle DCB, starting at D, going down to C, and over to B. Are the triangles congruent? Okay, now they're not asking us to perform a proof here, they're simply asking us to determine if these two triangles are congruent based on what we know. The definition of a rectangle is a quadrilateral with 4 right angles such that opposite sides are congruent. Right? So AB should be congruent to DC, AD should be congruent to BC, right angle, right angle, right angle, right angle. Right? So that's what should happen based on the fact that it's a rectangle. All right? The stuff that's important to us is what they've got marked. Specifically, I know that AB is congruent to DC, and angle ABC and angle DCB are right angles. We're trying to establish these two triangles, the red and blue triangle, are in fact congruent. They are right triangles, so we have our list of right triangle properties for congruence. That list includes hypotenuse leg, leg angle, and hypotenuse angle. Whenever you're trying to prove congruence of triangles, you want to establish what kind of triangles you have to see what you have to determine. You also have the more general ones of angle, angle, side, angle, side, angle, side, angle, side, 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 if you want to go that route. But since the right triangle ones have fewer things to show, it tends to be easier to work with those. If you take a look at what we know already, AB is a leg and CD is a leg. So that gets me to these 3 now. Probably one of these 3 if I'm trying to show them to be congruent, since I already have a leg in common. Okay. Looking just at the red and the blue triangle, can anybody tell me specifically if there's any pair of legs or angles or hypotenuses that would have to be congruent based on what you're looking at for any reason whatsoever?
The angles.
Which ones?
The right angles.
Well, the right angles, yes. I'm saying based on, we've already got this, right? The right angles are congruent, but that makes right triangles, right? So I know that I want to show congruence. Triangle ABC and triangle DBC or DCB are right triangles. I'm just making a list here of basically the statements of a proof. I want to state my given information, right? And then the given information leads me to the fact that I have right triangles. I don't need the fact that these are congruent because I'm using that to use the fact that they're right triangles. So anything else in these 2 triangles that is not already mentioned right here that has to be congruent to something else? For any reason that you've learned this year whatsoever? BC, what about it?
It has to be equal to this one.
Because?
Because it's the same one.
It's this exact same piece, right? The 2 triangles share a side BC, and that side equals itself, it's congruent to itself. BC is congruent to BC because overlapping triangles have a shared side here, and that's the reflexive property. And again, that's used quite often in these scenarios. Right? When we're trying to show congruence of things, things having a shared side is a pretty common occurrence, so it's something you should be looking for. If you look at BC on both triangles, for triangle ABC, it's a leg. For triangle DCB, it's also a leg. So, leg correspondence, that tells me that the two triangles must be congruent because of leg. Identify the corresponding sides and angles. So, corresponding parts. Okay. The corresponding parts would be the pieces that are the same, right? And if I take a look at the names of the triangles they give me, ABC in that order, DCB in that order, I know that angle BAC and angle D, so CDB, would correspond. That'd be this angle up here, this angle up here. The two right angles, of course, correspond to the angle ABC and angle BCB. And then finally, the angle C and angle B, which would be down here for the angle ACB and angle DBC. In each case, I'm using 3 letters to represent these because if I say angle A, which one? The little one up here, the little one over there, or the right angle? The angle D, the little one of the right angle. So when there's more than one angle happening in the vertex, you can use 3 letters to name it. So if I'm just marking these, you can see it red on this instead of blue. This angle down here in red matches this angle down here in blue, and this right angle in blue matches this right angle in red. The other corresponding parts would be the sides, and the sides are the ones that are congruent to each other. So I know that side AB and DC and side BC and BC, and then AC and BD. So this one's congruent to itself, this one is congruent to this one. All right, so if you look at the problem here, and then once we've got the fact that, again, here's everything we need to show by leg, but the two triangles are congruent. So are the triangles congruent? Yes, triangles are congruent. Okay, there's Y. There's the corresponding parts. We know once the triangle's congruent, all the corresponding parts are also congruent, so I got to mark that way on the picture. Notice all we did was start off with a rectangle and diagonals. And notice that the diagonals ended up being congruent to one another. Okay, so that could be a theorem that we have proven here, basically, but we didn't do a formal proof. But if you have a rectangle, the diagonals should be congruent to one another. Because again, the only fact I used was a rectangle, right? That's a rectangle, which meant those are congruent, these are right. These have to be congruent to one another because those triangles have to be congruent. Oops. So, unless they formally say write a proof or given and prove and whatever, again, just stating facts and then things that you know to be true, that's kind of how you go about doing it. You don't have to necessarily write the reasons, but just know the reasons as you write it down. Go through a logical sequence there.